Hello everyone, in this tutorial we are going to solve some of the linear algebra questions that are asked in the GATE exam in the previous year. So let's start with question number 1. Okay, so question number 1 says for what value of p the following set of equations will have no solutions. Okay, we have two equations here, x and y are our variables, and here p is unknown, and we have to find the value of p such that this system, these two equations have no solution. Okay, so first of all let's form an augmented matrix from these two equations. So what we are getting is simply here it is p, we have to find the value of p. Okay, now let's apply some operation on this matrix, some row operation to reduce it into echelon form, from where we can compare the rank of this matrix and whole augmented matrix, and we can find the value of p for no solution of this system. So first of all, let's divide this first row by 2, because and then we multiply with 3, and we are subtracting from uh, third row, sorry, second row. So let's first r1 by 3 become our new r1. So after that, sorry, not 3 here, 2 r1 by 2. So here simply 1, 3 by 2, here 5 by 2, here the second row is remain as it is. Now we are multiplying uh, first row with minus 3 and adding in the second row. So let's write r2 minus 3 r1 become our new r2. So let's do this operation. The first row is remain as it is. Sorry, here it is a vertical line, 5 by 2. Now here we got 0 because 3 minus 3 comes from the first row, and we have already positive 3, so we get 0. Now here we get p, we have to multiply it, this first row, with minus 3, so we are getting minus 9 by 2 here, and here what we are getting simply 10 minus 15 by 2. Okay, so let's further simplify this matrix. So simply the first row is remain as it is, 5 by 2. Now third row, sorry, second row, we have to simplify simply this third element. So here 20 minus 15, so we are getting simply 5 by 2. Now if suppose this element here, this element will become 0, then what we are getting, the matrix look like 1, here 3 by 2, here 5 by 2, here 0, 0, and 5 by 2. Now you can compare the rank of this coefficient matrix, which is 1, and the rank of this whole as an augmented matrix, which is 2. And you can see this both rows, both rank are not same. So we can conclude that for if this element will be 0, then the system has no solution. No solution. So here we can make this element as 0 by just equating equal to 0, and now find the value of p, which is nothing but 9 by 2, which is 4.5. So here we got our answer for the p, we got 4.5. If the value of p is 4.5, then these two equations are never intersecting, or in the other words, they have no solution. Okay, now let's solve question number 2. question 2 says, okay, so question number 2 says, uh, the two eigenvalue of the matrix we have given 2 cross 2 matrix have the ratio. Okay, we have given the ratio of two eigenvalue in the form of 3 1 for the value of p equal to 2. Okay, we have given this value, and what they are asking, what is the another value of p for which the value of I sorry for which the eigenvalue has the same ratio. Okay, so one value for p we have given, and they are asking about the another value of p such that the ratio of this uh, eigenvalue of this matrix will be remain 3 gem 1. So okay, now we have to make first of all two equation, and from that we can solve the for value of p. So first of all, let's write, we know from the property of the eigenvalue that the trace of the matrix will be equal to the sum of all eigenvalue. So here let's assume this matrix has two eigenvalue as lambda 1 plus lambda 2. Now if we add this both values, so what we're getting is just simply the trace of this matrix, which is nothing but 2 plus p. Okay, and now another property is that the multiplication of two eigenvalue gives the determinant of this particular matrix. So here determinant will be 2p minus 1. Okay, now the condition here is given that the eigenvalue have the ratio of 3 1. So let's assume lambda 1 by lambda 2 equal to 3 by 1. Now here we can say lambda 1 will be 3 times of lambda 2. Okay, so uh, okay, so let's replace lambda 1 in this second equation in terms of 3 lambda 2. So what we are getting simply just 3 lambda 2 square equal to 3p minus 1. Now use this first equation to find the value of lambda 2 in terms of p. So here we know lambda 1 equal to 3 times lambda 2. So simply put value of lambda 1 in the terms of lambda 2. So what we are getting 3 lambda 2 plus lambda 2 equal to 2p plus 2 plus p. Now here what we are getting simply just lambda 2 equal to 2 plus p divided by 4. Okay, so we have got the value of lambda 2 in the terms of p, which is here the variable, and we have to find the value of p. So let's replace this lambda 2 here, and after that we are getting the uh, equation in terms of p square. From that we can find the value of p. So let's do it. So here 3 as it is. Okay, we have to square this term, 2 plus p by 4 whole square minus equal to 2p minus 1. So let's square it. So here 3 by 16, 4 plus 4p plus p square equal to 2p minus 1. So let's simplify a little bit. So here 12 plus 12p plus 3p square equal to this 60 will be multiplied with this term. So 32p minus 60. So let's bring all this term in the left hand side. So after that I get 3p square. Here we are simply getting minus 20p because already here 12p is there, and 13 32p will come this side and become negative. So we get 20p, and here positive 12 is already there and 16 is added in that. So we are getting 28 into 0. Okay, so now we have got the equation in terms of p, and which is second order. So let's find the root of this equation simply. So we are finding the values of p1 and p2. We are going to simply use this equation, this minus b plus or minus under root b square minus 4ac divided by 2a. So just simply put all this value. So here positive 20, because we have to multiply this coefficient with minus. So minus 20 is already there and we multiply with minus, so we get positive 20 plus and minus under root of, we have to square this term 20, so we are getting 400 minus, we have to subtract 4 times this a 3 multiply with 28, okay, and divide by 2a, which is nothing but 2 into 3. So after that we are getting simply 20 plus or minus, let's simplify it. 400 minus 4 multiply 3 with 28, so we are getting simply just under root of 64 divided by here 6. So let's take square root of this 64, it's simply 8 divided by 2. Now take one time positive and one time negative, so we are getting the value of p1 and p2 respectively. So first let take positive, so we are getting 28 by 2. Now subtract 8, sorry here 6 not 2, 6 here. Now subtract 8 from 20, so we are getting 12 by 6. If we simplify, then what we are getting simply just 14 by 3 here within first value and here 2. Okay, so these are the value of p. We got two values. uh, P equal to 2 is already given in the question. Here one value is given and they are asking about the another value of p such that this matrix has a same still same ratio of these eigenvalues in the form of 3 sum 1. So we have find out another another value of p, which is 14 by 3. So option C is the correct one. Okay, let's solve question number 4. Question 4 says the smallest and largest eigenvalue of the following matrix. Okay, so they are asking about the smallest and largest eigenvalue. So here we cannot use any property of eigenvalue like trace and determinant is equal to multiplication by eigenvalue. Here we have to find the characteristic equation of this matrix and find the determinant, and equate is equal to 0. From that we can solve for the eigenvalue and we have to find the smallest and the largest one. So let's form the characteristics equation from this matrix. So just simply we have to make, let's say this matrix is A, let's call it A. Then here we have to just simply A minus lambda I, and we have to take the determinant of this matrix and equate is equal to 0. So let's form this determinant. So here 3 minus lambda minus 2, 2, 4 minus 4 minus lambda 6. Now we have to equate this determinant equal to 0. Now let's find determinant in terms of this lambda. So I will do here. So just let's multiply these two terms. Okay, we have to subtract multiplication of this number, which is minus 18. So minus is there, so will be plus 18. Okay, now the second term, here minus 2 is there, so we have minus 2 from the expansion equation and minus 2 here, so we get plus 2. Now we have to multiply this element 4 and 5 minus lambda, so we are getting simply 5 into 4 minus lambda. We have to subtract the multiplication of these two number, which is 12. Now the last term it will be, we have to multiply this both minus 12 and we have to subtract this multiplication of this both. Okay, we have to equate all equation are equal to 0. So let's simplify this equation further. So simply 3 minus lambda into 5 minus lambda minus 4 minus lambda. Here let's multiply this bracket with this 18 here. So we are getting 18 into 3 minus lambda. Let's multiply this 2 with whole bracket. So 8 into 5 minus lambda minus 24. Let's do the same thing with this bracket. So here again minus 24. Here minus 4 into minus 4 minus lambda equal to 0. Now let's write the first term as it is. Now let's multiply this term with uh, the bracket. So here 18 multiply with 3. So we are simply getting 54 minus 18 lambda. Here 8 multiply with 5. So we are getting 40 minus 8 lambda. Okay, so add these two value. We are getting minus 48 plus 16 plus 4 lambda equal to 0. Now let's multiply these two bracket. So 3 minus lambda minus 20 plus 5 lambda minus, sorry, here it is minus 5 lambda now plus, here this 5 multiply with this minus lambda, so minus 5 lambda. Now this minus lambda multiply with this minus 4, so we are getting simply plus 4 lambda, and the last term will be lambda square. Okay, now here you can see minus 18 lambda here, minus 8 lambda, so minus 26 lambda, and plus 4 lambda here. So in output we are getting simply 22 lambda minus 22 lambda, because here 18 18 here, uh, 8 26, we have to subtract 4, so we are getting simply minus 22, and here constant term will be 54 minus 48, which is 6 plus 14 plus 16. So 14 plus 16 will be 56 plus 6. So we are getting simply 62, positive 62 equal to 0. Now let's simplify again further. So here lambda square minus lambda, here 5 lambda, subtract from the 4 plus 4 lambda, so we are getting minus lambda minus 20 minus 22 lambda plus 62. Now we can further multiply this bracket with this bracket and find the polynomial in the term of lambda cube, but it is not a necessary step here because they are asking about the largest and minimum. So we can directly go from the option and put the one by one value, and we are uh, checking the either this equation is satisfied by this value or this value by which option. So first of all, let put 1 here in the option A. So what we are getting simply 2 here, 3 minus 1 2 here, 1 minus 1. Okay, this one with cancel with this minus 1, we are getting simply minus 20 here, minus 22. Okay, we have lambda is 1 because we are trying for option A, plus 62. Now find what this equation give. It's minus 14 minus 22 and here plus 62. Okay, this will be minus 62 plus 62 will be 0. So we are getting the right hand side of this equation. This we have derived. So the option A is satisfying. First value we have 1 is satisfying this condition. Now okay, so we have also 1 in the option B. So we have to either say either 3 is satisfying this equation or 2 is satisfying. So let's check for 3 because it is easier. You can see the whole term this will be 0 because 3 minus 3 will be here we are getting multiplication with 0. So simply 0 this term. Here if you multiply it with 3, now put 3 here in the place of lambda. So we are getting minus 66 plus 62 will give minus 4. Okay, so we are not getting 0 here by from this equation. So we can say the minus 3 is the not eigenvalue of this matrix because it is not satisfying this characteristic equation of this matrix. So we can sure that the option B is the correct one. You can check by placing 2 in the place of lambda. So let's do it. Here we are getting simply 1. Here 4 minus 2 we get 2, and we have minus 20 here. So we are simply getting minus 18. Here we are getting minus 44 plus 62 equal to, let's uh, do the subtraction of this, sorry, summation of this both. So we are getting simply just minus 62 here plus 62 is already there, so we are getting 0. So you can see the lambda equal to 2 is satisfying this equation. So lambda equal 1 and lambda equal to 2 are eigen values, eigenvalue of this matrix. So option B is the correct one. Okay, now let's solve question number 4. Question 4 says, let A, we have given a matrix A in the form of Aij, where I and j represent the index of this corresponding element in the matrix. So here condition is given that I must be greater than or equal to 1 and j must be less than or equal to n. And here the other condition is that n must be greater than or equal to 3. Okay, so we have a minimum at least a 3 order matrix, and they are asking, sorry, they are saying the value of this element for a particular index ij, it is nothing but the simply just multiplication of uh, its index. So first of all, let assume that our matrix has a 3 cross 3 dimension. So let's, here we are getting a11, here a12, here a13, here a21, a22, a23, and here a31, a32, and here a33. Okay, 3 cross 3. This condition will be satisfied because it is given n is either equal to 3 or greater than. So we are using 3. So this condition will be satisfied. So now let's find the entries in the this place, in this place. Follow the, so what is question says the entry will be nothing but the simply just multiplication of these two number. Okay, simply just multiplication. So let's do here what we are getting, 1 multiply 1 with 1, 1 multiply with 2, 1 multiply with 3, 2 multiplied with 1, 2 multiplied with 2, 2 multiplied with 3, and 3 multiplied with 1, 3 multiplied with 2, and 3 multiplied with 3. Now we have got the matrix and they are asking about the rank of this matrix. Let's say it A. So they are asking the rank of this matrix. Now you can see the first row, second row, and third row are linearly dependent. So we can write like here first row will be 1, 2, 3. Now the second row is 2 times 1, 2 times 2, 2 times 3. Third row will be 3 times 1, 3 times 2, and 3 times 3. So you can see first row here it is multiplied with 2, here also 2, here also 2. In the third row we have multiplied the first row with 3, here and here. So you can reduce it by the row operation. So if you do, let R2 minus 2R1 become new R2, and R3 minus 3R1 becomes new R3. So what we are getting simply 1, 2, 3. Here all entries are remaining zeros. So we can say that the rank of this matrix A equal to 1. Now you can do for any order n cross n, and you get the same answer, rank as 2, because it does not matter you how much you are taking the matrix, because the entries are in the in this same sequence, so they all are linearly dependent. So we are getting the rank of this matrix will be 1 for the any order. So the correct answer is the option C. Okay, let's solve question number 5. Question 5 says, let A be is an n cross n matrix. Okay, we have given A will be our n cross n matrix, n cross n matrix with rank. Okay, we have given the rank of this matrix A equal to small r, and the r is in between 0 and n. So they are asking then the ax equal to 0, which is nothing but the uh, representation of equation in the form of matrix. Here A is the coefficient matrix, coefficient matrix, and here x is our unknown vector x1, x2, x3, or in the form of other variable abc. Here we have a homogeneous system because right hand side here is 0. So they are asking about the number of independent solutions. Okay, so P has independent solution where P is khali jagya. So this system has P independent solution, and they are asking about the value of this P. Now, first of all, here we have to understand uh, what this independent solution means. Okay, so simply independent solution, it simply says that we have to select, suppose let's say our system of this equation are given in the x, y and z variable. So if we have to assume z equal to any number, let's say t, and t belongs to any real number, so we can say that the here the z is the independent variable, and the x and y will be depend on this t variable. So we have find we will be find the value of x and y in the term of t only. So here the only z is our independent variable. Now, if the matrix has a rank deficiency, then and then we get the independent solution. Otherwise, we get the unique solution for x, y, z. So here it is given the rank of this matrix is R, and where R is less than the dimension of this matrix, here which is n cross n. So we can say that there is at least n minus R rows of this matrix will be 0. Okay, they are completely 0 rows, n minus r row, because here we have n rows and we are getting the rank is r. So here we are getting r row which are non-zero with non-zero entry, and which are linearly independent, and the remaining n minus r row will all have 0 0 as entry. So we can say at least n minus r solution of this equation has independent. So option B is the correct one. Okay, let's solve question number 6. Question 6 says the following set of three vectors. Okay, we have given three vectors is linearly dependent when x equal to. Okay, so they are saying that what is the value of x for which these three vectors will be linearly dependent. So we have to simply just take the determinant of this three variable, because we know if the any two rows or column of any matrix are linearly dependent, then its determinant must be 0. So let's form its determinant here. First column is 1, 2, 1, x, 6x, 3, 4, 2. Now we have to take the determinant and equate is equal to 0, because we are interested in finding the dependent characteristics of these three vectors for what values of x. So make these three vectors of determinant of these three and equate is equal to 0. So let's find the determinant. From there we can solve for the x. So let's 1 into this 12 minus 4x minus x into simply this 4 minus 4 plus 3 into 2x minus 6 equal to 0. So now here 12 minus 4x, here this element becomes 0, here plus 6x minus 18 equal to 0. So let's 2x minus 6 here. So we are getting equal to 0. So we get x equal to 3. If the value of x here in this second vector, if we select the value of x here is as in 3, then these three vectors are linearly dependent. So option D is the correct choice for value of x. Okay, now let's solve question number 7. Question 7 says for the matrix we have given 2 cross 2 matrix and we have given a vector. If the matrix, if this vector is an eigen vector, then the corresponding eigenvalue. Okay, so they are asking for what eigenvalue this vector will be the uh, eigenvector of this matrix. So we have to find the eigenvalue which is corresponding to this eigenvector. So simply we know the basic definition of eigenvector. If let's say any matrix A and we multiply this matrix with its eigenvector, then in the output what we are getting is simply just this vector here as it is, because if and if, then if it is an eigenvector, then and then we are simply getting vector, this vector here and some scaling factor which is lambda, and this scaling factor is corresponding to the eigenvector, sorry, eigenvalue, and this vector x is nothing but the eigenvector. If this condition is satisfied by any matrix and vector, then we can say this vector is an eigenvector and this value is an eigenvalue of this matrix A. Here A is the matrix. So let's write here matrix first 4, 3, 3, 4. Now let's multiply it with this vector which is 1, 1. So let's do the multiplication. So simply we are getting here 7, 4 plus 3. In the second element also we are getting 7. So now we have to take the some scaling factor out from this vector, such that after that taking out we get this matrix is in same. So let's write this matrix first 1, 1. So now if we take 7 out, comes out from this vector, then we get 1, 1 here in the place of 7. So we are getting the same vector which is the initially we have. So here we can say the our eigenvalue for this eigenvector is 7. So we have find the corresponding eigenvalue which is nothing but simply 7. Okay, now let's solve question number 8. Question 8 says uh, the number of solution of a simultaneous algebraic equation. Okay, they are asking about the number of solution of this system. So first of all, let's form this equation in the form of uh, all variable in the left hand side and the constant term are in the right hand side. So here let's simply write in this way 3x plus y equal to 5, here minus 3x plus y equal to 3. Now you can simply see from here, if you solve for the x and y, then you cannot get any solution, because here if you multiply this equation with plus sign, sorry, if we multiply this second equation with minus and it's simply adding, then what we are getting in the left hand side will be simply 0, 0, and the right hand side we are getting non-zero value, and which is not possible. So we can say that this system has zero solution. So let's do it by the matrix. So here we have to write the coefficient matrix 3, 1, minus 3 and 1, and here we have to write the right hand side Now you can see these both rows are linearly dependent, so we can perform row operation like R2 minus R1 becomes new R2. So the first row is remain as it is. Now here we are simply getting 0 0 and here minus 2. So now you can see the rank of this coefficient matrix which is 1 and the rank of the as a whole augmented matrix which is 2 here in this case. So we can say these both rank are not equal, and from the basic concept of this simultaneous equation we can say that if the rank of this A matrix and A augmented B matrix are not same, then the system has no solution. Okay, you can also conclude from here, and you can also conclude from direct observation this by observing by these two equation. So we have zero solution for this system. Okay, let's solve question number 9. So question 9 says the eigenvalue of the matrix. Okay, so they are asking about the eigenvalue. So let's first of all call, let's say, vector A, sorry, matrix A. So we have to find the determinant of A minus lambda I and equity is equal to 0. So let's find determinant. Here minus lambda, here 1 minus 1, and here simply minus lambda. We have to find the determinant and equity is equal to 0. So let's simply for solve for the lambda. So lambda square plus 1 equal to 0, and then lambda square equal to plus or minus 1. Now, sorry, not plus or minus, simply minus 1 minus 1. Now because the square is negative, so we have got the imaginary value which is nothing but plus or minus I. So we can say that lambda 1 equal plus I and lambda 2 will be minus I. So we have got the values in the form of I and minus I. Is I imaginary part here. So we can say option D is the correct answer. Okay, now question 10 asking about the rank of this matrix. We have to find the rank of this matrix. So simply we have to perform some row operation to reduce it into echelon form. Sorry, here it is 3. So let's what we are first going to apply is just simply let's subtract this row 5 times from first row. So R1 minus 5R2 becomes new R1, and let's subtract 3 times this second row from this third row. So R3 minus 3 times R1 will be give new R3. So let's write this matrix after this operation. So here simply 0, here 10 remain as it is, here again we get 0, the second row remain as it is. Now the last row will be here 3 minus 3 is 0, here 6 again remain as it is, here again we are getting minus 6, we have already plus 6, so we are getting simply 0. Now you can see this row 3 and row 1 are linearly dependent. We can also reduce it, so let's do it. Let's divide first row by 10, R1 by 10 becomes R1, new R1. So here simply 1, we are getting 1 in the place of 10, and here 1 0 2, the third row remain as it is. Now we can apply further one operation which is R3 minus 6 times R1 will be new R3. So let's write 0 1 0 1 0 2 0 0 and 0. Now you can see the number of non-zero rows this matrix has is 2. These two rows are non-zero and this last row is 0. So we can say that the rank of this matrix, rank of this M matrix will be 2. So we are getting just rank is 2 for this matrix. So option D is the correct answer. And thanks for watching.